Boys and girls, welcome to video 9-2 on conic sections, circles, and ellipses. Let's start with circles, and this will be lickety-split quick. Circles are a set of all points that are equidistant to a given point. We call that given point the center point. Of course, this distance right here we call the radius. The equation of a circle is right here. It is x minus h squared plus y minus k squared is equal to r squared. That just comes right off of the distance formula. We now, of course, know that r is my radius. And as before, and you guys know this very well, my center point is h, comma k. Let's go on to ellipses. Ellipses are a little bit more complicated. Ellipses are circles that are stretched out a little bit. They're ovular. Okay. An ellipsis is a set of all points such that the sum of the distances to 2 points, which we call the foci, is always equal. So in other words, on my ellipse, let me change colors here. On my ellipse right here, this distance to this focus to the left focus, plus this distance to the right focus, that is some constant. That distance would be the same, that constant would be the same as this distance plus this distance. This distance plus this distance, all of these distances add up to the same thing. Okay? So, there are several parts to an ellipse, and ellipses are much more easy than parabola. If my ellipse is horizontal, it is in the form of x minus h squared over a squared plus y minus k squared over b squared is equal to 1. This distance a, let's do this in purple. This distance a goes from center point to the edge of my ellipse the long way. 2a we call the major axis. So this distance right here would be 2a. We'll do this in blue. From the center point to the edge of my ellipse, the short way is called b. 2b, of course, is the minor axis. And c, the distance c, we'll do that in yellow, goes from the center point to the focus. That's called c. Okay. 2c, of course, would be 2c would be the distance from focus to focus. Okay? A, B, and C are related Pythagorically, the Pythagorean theorem. In this case, A is our longest distance, so B squared plus C squared will always equal A squared in an ellipse. If the ellipse were vertical, the only thing that would change right here is that the A, the bigger number, would be under the Y term, and the B, the littler number, would be under the X term. Now let's try something. Ooh, one more thing. The eccentricity of an ellipse is always the value c over a, and eccentricity ranges from 0 to 1. A perfect circle has an eccentricity of 0, and if you stretch your circle out so much that the ellipse becomes a line segment, then that eccentricity is 1. Okay, we're going to play that game. This game is called Name the Stuff. Alright, here we go. Let's look at this ellipse right now. First of all, let's decide that this thing is vertical as opposed to a horizontal ellipse. So I know that my A, my bigger number, is going to be under the Y terms when I add these up. So let's start with the center. The center point is at 0, 0. Before we worry about the foci, let's come up with the major and the minor axis, because I'm going to get my foci with the C, which I'm going to get first by getting my A and my B. The major axis has a total distance of, the major axis is going to be right here, and that has a total distance of, it looks like 8, and 8 or 6 or 16. So my major axis is 16, but more importantly, A is equal to 8. My minor axis is going to be right here in blue. Notice that the minor axis has a total distance of 12. However, more importantly, we have 6 on each side. So my minor axis is 12, but more importantly, B is equal to 6. I know you're thinking 6, 8, 10, right triangle, but no. C, we need to come up with a C. Well, C, we know that B squared plus C squared is equal to A squared. Well, B was 6, so that's 36 plus C squared is equal to A squared. A was 8, so that's 64. Hey, Tara, what's 36? And what's the difference of 64 and 36?
24.
28.
28.
So C squared is equal to 28, so C is equal to 2 root 7. So we know that we're going to go 2 root 7 up. 2 root 7 is, root 28 is a little more than 5, so we're going to go, our foci is going to be about there and about here, okay? And we're going to write that as the first order pair is positive 2 root 7 comma 0. And my second order pair is negative 2, I wrote that wrong, sorry. Coming right back to you. X is 0, Y is 2 root 7. There's my first focus. And the second focus is 0 comma negative 2 root 7. Lastly, we focus on equation. I'm going to erase some stuff here just so we can see. And my equation, this is vertical, so this is actually going to be y minus k squared over a squared, a is my bigger number, plus x minus h squared over b squared, b is my littler number, and that's always equal to 1. So, in this case, h and k were both 0. A was 8 and b was 6. So this is going to be y minus 0 squared, or y squared, over 8 squared, which is 64, plus x minus 0 squared, or x squared, over 6 squared, which is 36, and that's equal to 1. And this, my friends, is the equation for the ellipse you see above. Let's try another. All right, let's name the stuff here. This is a good game. I like this game. Name the stuff. I have foci at 6, comma 2. And negative 4, comma 2. So there are my foci, which means certainly my center point is going to be halfway in between those two right there, and that's going to be at 1, comma 2. We can also know right now that this ellipse is going to be horizontal, because my major axis is horizontal. The major axis has both the foci and my center points. I know my major axis is 18 units. Okay, so let's just right now, let's let A equal 9. And I can kind of write these in right now. So my major axis is going to go out that far and go out 9 from there. So it's going to go out to about there. Right, they're going to be the edges of my ellipse. I do know that my C is the distance between my, this distance right here is my C. Okay, so that distance is 1, 2, 3, 4, 5. So that distance is 5. C is 5. So we're going to write that right there. And I can now come up with my B by using the Pythagorean relationship. So I know that B squared plus C squared is equal to A squared. And I almost said A there. B squared is what I'm looking for. C is 5, so that's 25. A is 9, so that's 81. 81 minus 25 is, Tara? 54. B squared is equal to 54, so that means that B is equal to 3 root 6. Okay, so 3 root 6 is, say, 54, so that's a little more than 7. So my major axis is going to go 7 up this way, and 7 down, 2, 4, 6, 7-ish, down 7 plus this way. And so my ellipse, if I were to draw it, looks something like this. Not bad if I say so myself. My minor axis is going to be 2 of my b's, which is going to be 6 root 6. And the equation is going to be x minus h, which is 1 squared, over a squared, which is 81, plus, let me get rid of this stuff, plus y minus k squared. K was 2, so that's y minus 2 squared over b squared. Well, b squared, if you remember, was 54. So that is equal to 1, and voila. There is our equation. Good.